In this video, we're going to go ahead and take a look at some examples from section 6.4 on confidence intervals for the variance or standard deviation. So before we do the examples, here's a bit of background information. So if the data are normally distributed, then we use what's called the chi-square distribution to get confidence intervals for the variance, okay, sigma squared, or the standard deviation, sigma of a population. Okay, so these symbols here, right, for the variance and standard deviation are for the population. Okay, if we're talking about the variance or standard deviation of a sample, okay, we use different symbols. Okay, so unlike confidence intervals for the population mean or population proportion, the sample variance, S squared, okay, will not be in the middle of the interval. Okay, in other words, it's not the midpoint of the interval. Okay, likewise, the sample standard deviation, S, is also not in the middle of the corresponding confidence interval. And what I mean by that is, right, these sample statistics, right, the sample variance, right, or the sample standard deviation, right, they are not going to be the midpoints of their respective confidence intervals. All right, and I may show you an example or two to clarify the point here. All right, so the other thing to remember is that the square root of the variance is equal to the standard deviation. So if you have a confidence interval for the population variance, sigma squared, okay, you must take the square root of the lower and upper limits of the interval to get the corresponding confidence interval for the standard deviation, sigma. Okay, so the first two questions I believe you can answer on your own, okay, by reading section 6.4. So more specifically, if you read the first page, right, you should be able to find the answers to those first two questions in the homework for section 6.4. Okay, so I'm going to go ahead and skip those. Okay, but let's go to look at problem 3. It simply says to find the critical values chi-square sub r and chi-square sub l. Okay, so the r and l stand for left and right, or right and left. Okay, for the confidence interval c and sample size n. Okay, so this is the confidence level expressed as a decimal. Okay, and then this is the size of our sample. So when we do the confidence intervals in this section, right, we won't necessarily need to look up the critical values from this probability distribution called the chi-square distribution. Okay, but in the next chapter, right, to do some of the hypothesis tests that we're going to do a little later in chapter 7, right, we may need to look up critical values from the chi-square distribution in order to perform the hypothesis test. So this problem and the next one are good practice for finding critical values from the chi-square distribution. Okay, so in any case, right, so our confidence level is 0.80, and our sample size is 22. So we're going to go to StatCrunch, go to Stat, select Calculators, and then select chi-square. Okay, so the typical chi-square distribution looks like this. Okay, it's kind of a lopsided curve. Okay, it's got a peak toward the left and it's got a long right tail. Okay, so the shape of the curve changes based on the degrees of freedom. So the degrees of freedom, okay, the degrees of freedom is equal to the sample size minus 1. Okay, so in other words, df degrees of freedom is equal to n minus 1. Okay, where n is the sample size. Okay, so going back to the problem, all right, our confidence level is 0.80 and our sample size is 22. So that means that the degrees of freedom for this problem is 21. Okay, so df is 21. All right, and we want the right-hand critical value. Okay, so we're going to select the greater than or equal to symbol. All right, and we're going to type in, actually, this is actually a little easier. So if we select between, okay, so if we select between, type in the degrees of freedom, Okay, and then enter the confidence level in this box here, so 0.80. Okay, you're going to get the critical values in these two boxes. Okay. Okay, so the shaded part in red is the area underneath the curve, which is 0.80. Okay, so the right-hand critical value is 29.615. Okay, so in other words, when we look up critical values from this chi-squared distribution, okay, we're usually going to round them to 3 decimal places. Okay, so the right-hand critical value will appear here, and then the left-hand critical value will appear here. Okay, so chi-square sub r will be 29.615. Okay, and then the other critical value, chi-square sub L, the left-hand critical value, when rounded to 3 decimal places, okay, that 9 gets rounded up to a 10, okay, so you put a 0 there and then carry the 1 over to the 3, and then 1 plus 3 becomes 4. Okay, so when rounded to 3 decimal places, right, the left-hand critical value is 13.240, okay, when rounded properly. So 13.240 will be the left-hand critical value. Okay, and you'll notice that the right-hand critical value is always going to be larger than the left-hand critical value. Okay, so if this is smaller, if you get an answer that's smaller for the right-hand critical value than the left-hand, right, you might be doing something wrong. Okay, let's check our answer. Okay, let's try the next question. So the same thing, we're looking for the critical values of the chi-square distribution, okay, for the given level of confidence, and then the given sample size. Okay, so the level of confidence is 0.98, and our sample size is 27. Okay, so that means the degrees of freedom is 27 minus 1, okay, which is 26. So you can actually type in 27 minus 1 here. Okay, and the confidence level goes in this box here. Okay, just remember that you have the between option selected, not the standard option, but the between option, right, when looking up critical values from the chi-square probability distribution. Let's click compute. Okay, so the part in red here, right, is the area represented by the confidence level. So the area between these two critical values underneath this curve is 0.98. Okay, the total area underneath the curve is 1. Okay, just like for any probability distribution. Okay, so we have almost the entire curve here. All right, so the left-hand critical value when rounded to 3 decimal places is 12.198. So that's chi-square sub L. Now, so you know it's looking for the left-hand value, so 12.198. All right, and then the right-hand critical value, okay, rounded to 3 decimal places, so that one's going to get rounded up to a 2, so 45.642. Okay. All right, so these problems are not as hard as they look, okay, as long as you follow the directions. Okay, let's go look at problem 6 from the homework. That says that the diameters in inches of 17 randomly selected bolts produced by a machine are listed. Using 99% level of confidence to construct a confidence interval for A, the population variance sigma squared, and B, the population standard deviation sigma, and then interpret the results. Okay, again, so once again, so when you do any type of confidence interval, right, whether it's a confidence interval for the variance or standard deviation of a population or the population proportion or population mean, remember that the data must meet certain requirements. And although we won't spend any time verifying the requirements, it's important to know what those requirements are for future reference. Okay, so on the guidelines given on page 332, right, you have to verify that you have a population that has a normal distribution. Yeah, that's the first thing. So the method that we use to produce the confidence intervals in this section relies heavily on that assumption, right? You're dealing with data that are normally distributed and a population that is normally distributed. Okay, if not, then the methods in this section won't give accurate confidence intervals. Okay, but in any case, right, we're mostly going to assume that the population is normal. Okay, so let's go ahead and copy the data into StatGrunch. Okay, or if you're doing the homework on your own, you can click open in StackCrunch and it'll open up the data in a new spreadsheet. So I'm going to click copy to clipboard, Control C or Command C. Okay, and then find an empty column, paste the data. Okay, so part A wants us to do a confidence interval for the variance, sigma squared. Okay, so what we're going to do is we're going to go to stat, and we're going to select variance stat. And since we have only one sample of data, all right, since we have the actual data values, we're going to select with the data. Okay, select the column that contains our data. And since we're doing a confidence interval, we're going to select the second option and type in the confidence level as a decimal. Okay, and we can select confidence interval plot if you want to see a plot of our confidence interval. And let's go ahead and click compute. Okay, so this tells you that this is a 99% confidence interval for the variance, sigma squared. So the variance of this variable, right, which are the diameters of these bolts. Okay, it tells you the sample variance, okay, which is quite small, 0.079. Okay, the degrees of freedom is 16, which is the sample size minus 1, but we're really looking for the lower limit and the upper limit. Okay, so for the variance, okay, so to 3 decimal places, the lower limit is 0.037. Okay, and then the upper limit to 3 decimal places, or it will be 0.247. That 6 gets rounded up to 7, so 0.247. Okay, then it's asking us to interpret the results. So remember, right, when we write an interpretation, it must include the level of confidence. Okay, the parameter that we're estimating, okay, in the context of the problem, and then the confidence interval limits. So since this is a confidence interval for the variance, okay, it looks like answer choice B would be the most appropriate answer choice. Okay, so with 99% confidence, it can be said that the population variance, okay, for the diameter of these bolts is between, okay, and then you type in the confidence interval limits again, so 0.037 and then 0.247. All right, and then we're gonna do the confidence interval for the standard deviation in just a moment here. But I do want to mention that in our confidence interval plot, okay, notice that this is our confidence interval. So the left-hand side is 0.037. Okay, the lower limit is 0.037, and then the upper limit is 0.247. Okay, right. So what is this dot here? Right, it's obviously in between the lower limit and upper limit, but notice that this dot is not in the middle of the interval. Okay. So this dot here represents the sample variance. Okay, the variance of our sample. Okay, so unlike with the other confidence intervals that we've done, right, for the proportion and mean, okay, right, the sample variance is not going to be in the middle. Okay. All right, so the question is, right, how do we get the confidence interval for the standard deviation? Okay, so remember what I said earlier, okay, that the square root of the variance is equal to the standard deviation. Okay, so this is where we're going to use our handheld calculators. Okay, so we've got the upper and lower limits of our confidence interval for the variance. So to get the lower and upper limits for the standard deviation, okay, we're going to take the square root of those limits. So the square root of 0.037 is equal to 0.192. That's going to go in this box down here. So 0.192. Okay, likewise, the square root of the upper limit, 0.247, okay, is the upper limit for the standard deviation, which is 0.4969, so at 0.497. Okay, let's try that, so 0.497. Okay, and then we select the correct interpretation. So again, select the one that makes the most sense. So with 99% confidence, we can say that the standard deviation of the population of the diameters of these bolts, okay, is between 0.192 and 0.497.